Intel Arc GPUs have been tested for a pretty long time already by most of the popular PC hardware channels. However, top-end models were not officially released in Western countries until 12th of October. Does this review get late? Definitely not. Back in the release days, drivers were unstable, prices were awful, and comparing a 700-pound GPU with a 350 one is not something we are interested in doing, as well as spending $700 on Intel Arc. Likely the prices are now a lot closer to MSRP, and during all these tests we didn't find any critical errors in driver's functionality, so we can clearly say that Arc as a product is ready. If it is so, let's find out how Intel Arc A770 holds against the mid-range sweet spot RTX 3060. Hello and welcome back to Hardware Lab. Main unit of each Intel Arc chip is an Xe core. Basically, Xe core in Intel Arc plays the same role as AMD's compute units or Nvidia's streaming multiprocessors. For unification of the comparison and specs in our video, we call it CUs, no matter who is the GPU manufacturer. Anyway, each Xe core contains 16 256-bit SIMD vector engines, which gives us 8 32-bit shader units per one vector engine, and 128 shader units per one Xe core. Another thing that can be found in Xe core is matrix engines that support 1024-bit instructions. One core has 16 of them as well. Those engines are super useful for matrix calculations, just like Nvidia's Tensor cores, and yes, they can be used to significantly accelerate AI calculations. One more exciting unit located in Xe core is a hardware ray tracing accelerator. Before talking about the accelerator properties, I should explain what the ray accelerator actually do. There are two key calculations that are required to run DXR ray tracing. Ray, which is in case of ray tracing a vector form of data that is traced from the camera position and perspective, changes its direction when it intersects a polygon or, in most cases, a triangle. The bounce direction, strength and color change must be considered. This intersection calculation is called ray and triangle intersection. The other type of calculation is a ray and box intersection. Since calculating intersections with all of the available geometry is a super demanding task that provides a lot of useless data, the bouncing volume hierarchy concept was used to accelerate this process and reduce the amount of useless workload. The best way to understand BVH concept is to think about it as about the tree of possible ray and triangles intersections. All the geometry in BVH is covered with large boxes, and the GPU first checks the box intersection rather than checking actual complex geometry. If ray intersects the box, then the box gets divided to smaller boxes, and so on. The boxes that don't receive any rays are not taken into account. Ray accelerator itself in Intel Arc is not only capable of calculating ray and triangle intersection, but also features BVH boxes and triangle intersection calculations, like Nvidia and unlike AMD. But what AMD and Intel have in common is a high frequency. While Nvidia's Ampere GPUs are bouncing around 2 GHz, Intel Arc and AMD's RDNA 2 reach around 2.4 without any issues, and ray tracing accelerators just work on GPU clocks. Furthermore, Intel Arc Ray Accelerator also has its own dedicated cache structure. Intel doesn't post the amount of this buffer, but stated that it is present. So let's look at the numbers. Single Intel Arc Ray Accelerator can calculate 12 BVH box intersections per cycle and 1 triangle intersection per cycle. There is no data for BVH box calculation speed for Nvidia Ampere, but as I can guess, it is at least 12 intersections per cycle as well, and 1 triangle intersection per cycle. Coming to AMD, their approach of hardware ray tracing provides only 4 BVH intersection per cycle, and as well 1 triangle. So here they are, the theoretical numbers of ray tracing calculated speed. So to conclude, Arc A770 combines the advantage of both Nvidia and AMD approaches to ray tracing in terms of peak performance by providing more ray accelerators and on higher clocks, plus calculating large amount of BVH structures intersections a cycle. But to reach that peak performance, some data management is provided. There is a special block inside of each ray accelerator that is called thread sorting unit. The purpose of this unit is to sort the different lanes of RT tasks with the same length and type together. That strategy allows to utilize more available resources of each RT block. The whole system of sorting RT tasks is called asynchronous ray tracing, likewise async compute. This approach means that increasing the amount of shaders in ray tracing will allow Intel GPUs to lose much less performance than AMD or Nvidia's cards that don't have this feature. Talking about memory subsystem, each Xe core features 192 KB of low-level L1 cache, which gives more than 6 MB of just L1 cache itself on the most advanced chip. It almost doubles the amount of RTX 3060's available cache. Going further, I would like to add that the Intel Arc A770 has 16 MB of shared L2 cache, over 5 times more than on an RTX card. However, the pretty big L2 buffer is where the cache hierarchy stops. There is no third level of caching. Well, it's not surprising considering the amount of L2. The next step is obviously a VRAM, and flagship A770 features 16 GB of a standard GDDR6 on a 256-bit bus. It's quite a lot of VRAM for a mid-range, and with over 40% advantage over 3060 in terms of bandwidth, the memory subsystem in general looks very impressive. What doesn't look impressive is that the A770 competing with 3060 used 21.7 billion transistors. Find nothing wrong with that? RX 6700 XT for comparison uses only 17.2 billion. This is why the TSMC 6nm Arc A770 consumes significantly more power than the 3060 that is based on the Samsung 8nm. Yeah, this difference in density efficiency could be partly explained with the large amount of cache, but just partly. It also can mean that the production of Intel Arc in its current state is not as economically reasonable, but this is not accurate. In terms of the lineup, there are 3 available GPUs in Intel Arc family right now and 1 more planned. A580 is unreleased yet, and we are still not sure that it will be, since soon Nvidia and AMD will already release a next-gen mid-range cards that new generation of Intel Arc will need to compete with. Of course, the most balanced and well-done GPU in this list, in my opinion, is a 16GB version of A770 that we have in our hardware lab for today's test. 8GB buffer can be a strong limiting factor for both A750 and A770, so I suggest being careful with that, especially when the price difference is not that huge. A380 can be kinda alright extremely low-end card, and can probably have a strong fight with RX 6400, but really there are just too many perfect options on the used market for that price. So in this video we will battle the Arc A770 against RTX 3060. Some of you would say that RX 6600 XT would be also a good competitor for the A770, but you know, this test is only for the cool guys. It includes testing both 1440p and 4K, using ultra textures in modern games and so on. Forcing 6600 XT to take that test is like forcing a 5-year-old child to solve mathematical equations from university. Moreover, 6600 XT has lost memory and chilling with 3050, so we won't disturb it. Comparing A770 and RTX 3060 specs make me feel like 3060 has no chances to do anything against Intel Arc. But hey, remember they use different architectures with different approaches to ray tracing, to memory controller, and basically do anything else inside the chip itself. But just take a look at the Arc's flops amount advantage and memory bandwidth. Probably Intel's GPU will show itself a lot better in higher resolutions. But we will test that a bit later, and now I have one more thing to discuss. Of course, when talking about Intel Arc, there should be a section about its issues that can be surprised after using Nvidia and AMD GPUs. And the first problem that you are likely to meet appears when the GPU is first installed. Probably your PC just won't start, since on some motherboards, in our case on Gigabyte X570 Gaming Elite, running Intel Arc requires a BIOS update. Not a big deal for me, it is easier to do than it sounds, but still this issue should be mentioned. Moreover, monitoring Intel Arc is a nightmare. Latest version of MSI Afterburner has no idea what frequency this GPU is running on. Even Intel themselves probably don't know. So Afterburner only sees the load percentage of the Intel Arc by default, and monitor the VRAM frequency and even GPU temperature requires to use the HW Info plugin. Not a big deal, you think? Yeah, but HW Info cannot monitor the GPU frequency as well. The only program that can understand what the heck is going on with the sensor is GPU-Z. Let's take a look at its behavior. Without the load, driver only reports 600 MHz clock, sometimes, and sometimes it reports nothing, so it's not a surprise that all the monitoring apps decline to puzzle out what's wrong with this sensor. This weird behavior of the sensor is not the case, however, when 3D load is applied. The driver then starts to report a frequency consistently, and boom. If we start HW Info with applied 3D load, it can finally catch the sensor data and we can use it in Afterburner. Wait, did I say consistently? Sensor polling rate is so bad that it shouldn't be called consistently, so even God, if he was real, wouldn't know whether Intel Arc drops frequency or it doesn't. Okay, let's go a few steps back and remove the 3D load from the system. Do you think Intel Arc really works with a 600 MHz clock on the desktop without 3D load? Well, I don't know, but the power consumption level almost reached 40 watts. Yes, 40 watts without 3D load, so I guess 600 MHz is correct. Just compare it with RTX 3060 and yeah, this kind of GPU behavior without load was acceptable in 2014, but not today. And obviously because of this issue, fans on Intel GPUs never stop, no matter the load. Yeah, 2022. Everyone is talking about sustainability and reducing power consumption when it's not necessary, and Intel released a GPU that consumes a lot of power for nothing. Intel codec QSV is another nightmare that you're gonna meet using Intel Arc. The quality of recording using the same bitrate is on par with AMD and Nvidia, so that's okay. But what's not okay is the performance hit. Seriously, the benchmark recordings, to be at least representative somehow, we need it to go down to 6 megabits per second at 1080p with 30 FPS. That's a disgusting recording quality. Moreover, Intel Arc Control Center doesn't even allow you to record more than 30 FPS in resolutions higher than 1080p and limits the bitrate on 13 megabits per second. Just for comparison, standard recording on AMD or Nvidia records using in-game resolution with 60 FPS and 30 megabits per second just out of the box. Likely, there are some tools that allow us to test Intel's codec with the settings that are standard for AMD and Nvidia. Of course, I'm talking about OBS. So let's test Intel recording in 3 modes. First will be the optimized one that doesn't affect the performance. Second will be the Arc Control maxed out one with 1080p and 60 FPS and 13 Mbps. And the third one will use OBS and Nvidia standard recording 30 Mbps in QuadHD 60. As you can clearly see, the performance impact of hardware accelerated recording on Intel Arc is significant. A770 loses more than 10% in the mode that AMD and Nvidia run by default and without any meaningful drop. Just to be clear, all the data provided on the graphs further in the video were measured during the separate run than the recorded footage. All in all, yeah, Intel codec is a shame, and it is a problem for anyone who likes taking footages. Also, you have probably heard of resizable bar, the feature of PCI Express that allowed to directly control all the GPU memory by a CPU rather than controlling just a small amount of that buffer and transporting the rest of the data via outdated PCI protocol. The good news is that Intel Arc supports ReBAR technology. The bad news is that it works very poorly without ReBAR. Suddenly and unexpectedly, this is the moment to show you the first test segment against RTX 3060, ReBAR on versus off. Taking RTX 3060's result as a reference behavior, Forza Horizon 5 shows a slight improvement by using a resizable bar, however the performance without ReBAR is anyway fine. There is no frame time sparks or any other evidence of inconsistent performance.
As I lay here and recall years of wavering emotions, suppressed desires, volcanic explosions that retreat into dormancy. I wonder, could we ever flow
A770 shows the opposite result than 3060. Frame time sparks are super obvious without ReBAR and the performance is unacceptably low. It is hard to tell which result is better in Uncharted 4 on 3060, with ReBAR or without. All the differences here are perfectly explained by measurement inaccuracy. This game is definitely not very ReBAR intensive. almost a second starters without ReBAR each 10 seconds, and very poor result in general. Yeah, typical thing for Intel Arc in Uncharted. What went wrong, would you ask? Well, this is what Intel said in their Q&A video.
Our memory controller on our GPU happens to like fewer bigger transactions, and it has to do with the way the memory controller is designed and optimized for different memory technologies. But suffice it to say, if you bang on our memory controller with a lot of little transaction, it gets a little, you know, it's you know what I mean. So turn ReBAR on.
So they say basically nothing. Their memory controller prefers ReBAR to be turned on, and that's it. Well, at least now we know that the issue is connected to the architecture itself and not to the driver. That's sad, because it means it can't be fixable from a software side. And this is just a short list of CPUs that are not compatible with ReBAR. Ryzen's with Zen 1 and Zen Plus include the APUs AMD FX, Intel 9th Gen, 8th Gen, 7th Gen, and everything below that are not officially supported. So A770, as well as all the other ARC cards, yes, including A380, are definitely not a GPU for upgrading that old system. You can call it future-proofness, but I would definitely call it a massive disadvantage. Not because the difference is that high, but because the non-ReBAR results are super poor and uncompetitive. Oh, and about the future-proofness, Intel Arc doesn't support any API slower than DX12. Sure, you can run DX11 and 9 games, but they just use a D3D9 on 12 mapping layer instead. The efficiency of this layer is questionable, and we're gonna test the old games first. But one more thing I should state before the test section. All the tests were done on the driver version 31.0.101.3802. It was the latest available option when the tests were done, and a newer driver version that provides improvements to DirectX 9 wasn't used during the tests. Black Mesa is the most graphically advanced DirectX 9 game, and it runs poorly on A770. FPS is a lot lower than a 3060, frametime graph is full of sparks, and awful visual artifacts make the game unplayable. Yeah, this is not a joke. These are modern GPUs tested on CSGO. Well, of course both GPUs are CPU limited here, but anyway, the game acts weirdly with that GPU-CPU limitation stuff. Take a look at performance. Something is definitely wrong with Intel Arc. Oh, and do not pay attention to the minimum FPS drops. This is just a benchmark specific, in real gameplay the drops are not as huge of course. according to sensors, EDS2 is strongly CPU limited on A770, but just take a look at 3060. In some scenes the GPU limitation is obvious, and the frame rate is a lot higher. Final Fantasy XV test is the best example of the benchmarks that doesn't require any comment. Maybe just a sad face of Linus. But yeah, I have the answer why this thing happens here. Final Fantasy uses a lot of Nvidia's proprietary GameWorks, and some of these effects, such as hairworks and voxel ambient occlusion, are turned on here. From some people's points of view, it makes the test unfair. But why then AMD's cards don't struggle so much in this game then? Alright, let's test the game without GameWorks as well. Well, the improvement of Intel Arc's performance here is huge, and it looks like the game works just fine now. But that is before comparing with 3060 that doubles A770's result. Yes, this is the Steam DirectX 11 version of Quantum Break, and the DX12 version of this game would probably run a lot better on Intel Arc. But even DX11 runs alright, almost providing the 3060's performance. The frame rate on the Arc side is less consistent than on 3060, and the sensor reports underload on the GPU. It almost looked like a CPU limitation, but you know, 12 cores, Zen 2 over 4 GHz, and FPS lower than 60? No, that's not true, and 3060 proves that. First win for Intel Arc so long, but just take a look at the advantage, it's ridiculously huge. Well, the game runs using OpenGL as an API. That can be an explanation of the result, but this is not a typical type of a game. It uses custom software ray tracing implementation, as well as voxel graphics and advanced voxel physics. So the game demands a lot on computing, and just remember how fat Arc's chip is. Kinda reminds me here of the GCN. And for this result, well, I can't properly explain that. Intel Arc provides the same average but more consistent performance in this game. Yes, even when it doesn't natively support the DX11 API. Alright, this game is pretty memory bandwidth demanding, so it can be the explanation, but I'm not sure. Good for Intel Arc, by the way. Overall, the results of compatibility layer behavior are a bit disappointing. Performance in old games is not something you should normally pay a lot of attention to when buying modern cards, because, you know, the game will be playable anyway at maxed out without any issues. But this is not the case for our A770. Still, remember they were tested without the latest driver improvements. This GPU behavior could be at least improved manually by installing a DXVK extension. The DXVK tool is mostly used by Linux gamers, and if you are interested in detailed explanation and testing of that feature, I strongly recommend you watch our video about Linux gaming. Seriously guys, we are kinda proud of that video, it's very cool. Okay, DXVK can be run on Windows as well, but it is not useful in most cases. But having a GPU that doesn't support DX9 and 11 on architectural level sounds like this tool can change a lot. So let's try DXVK in the games that work weirdly and definitely needs to be improved. Black Mesa is fixable with DXVK, however the fixes are quite complicated. First, the DXVK installation should be done in the bin folder, not in the main one with exe file. Second, DXVK ruins the UI game menu, so the older version of UI must be run. This is done via boot argument. And finally, third, pure DXVK doesn't fix artifacting image and incorrect lighting. Fixing that requires adding a few more boot arguments that would mask Intel Arc GPU to Nvidia for the game. The results of all that manipulation with DXVK is quite impressive. The performance improvement is massive, graphics looks exactly in the way it should, and yeah, there are shader compilation starters, but they feels a lot better than consistently inconsistent performance on DX9. One more massive improvement to performance by DXVK can be found in Final Fantasy XV. Frame rate is still bad? Yeah. FPS is still low? God yeah it is. But at least it allows to use Hairworks and VXAO with 30 FPS, not with 9. Technically, Quantum Break with DXVK renders more frames than without and fixes GPU utilization. But the game with DXVK feels so stuttery that I would definitely go for native DX11 instead, thank you. Moving to nowadays and modern APIs, and the first result that we got is already impressive. Intel Arc works just better in Far Cry 6, and the advantage is massive in some scenes. Overall, the lowest FPS on Intel Arc is higher than the average on 3060. Wow! Recently released Callisto Protocol prefers Intel GPU as well. In case of A770, FPS doesn't drop lower than 30 at maxed out settings, at least in built-in benchmark and without recording. RTX 3060 is just doing significantly worse. First game that used Vulkan API in this test, and damn, the advantage of A770 is unbelievable. What do you think, guys? Can it even be faster than 6700 XT or 3070 in this game? After Strange Brigade, Forza Horizon 5 result don't surprise a lot, but still, Intel GPU is noticeably faster. Unlike Forza, the advantage in Watch Dogs Legion is huge on the Arc side. Again, I have no idea why it is how it is, but yeah, the game works a lot smoother on Intel Arc and it gets closer to 60. Perfect for the VRR 40 to 60 range. Tuning some settings would definitely provide a fixed 60 experience. On ultra settings, same can't be said about 3060 by the way.
Why can't this moment last forevermore?
And one more Vulkan game, and one more impressive result from A770. Here I want to talk a bit about VRAM consumption. As you probably mentioned, VRAM consumption on Intel Arc is higher than on 3060. This is probably connected to the higher VRAM buffer itself and the VRAM consumption scalability, because the same thing can be found on other Nvidia and AMD GPUs. What cannot be found on AMD and Nvidia is the sensor reporting 17 gigs VRAM consumption on a 16 GB card. Intel, what's wrong with the sensors? Why are they acting so weirdly? Oh, and guys, press F to 8 GB cards in Sniper Elite, even 12GB 3060 got VRAM limited. At first glance, Uncharted 4 is another slight win for Intel Arc. But firstly, it took decades to compile shaders here on Intel Arc. Seriously, over 20 minutes of shader compilation? Is it a joke? And yeah, performance consistency on Intel Arc is worse. The game drops FPS just slightly, but it happens each 10 seconds or so. Obviously not as bad as in ReBAR off test, and the game in general feels really smooth, but I would say it's a win for 3060. You were thinking we talked a lot about RT structure and didn't test RT? No way we are doing that. Far Cry with RT runs better on Arc GPU, so yeah, congrats, it's a win. However, the FPS drop from turning on RTFX on Nvidia is smaller. Looks like this game doesn't benefit a lot from Intel's async RT implementation. Forza Horizon 5 is another story. The performance drop on 3060 is a bit more significant in this game. Arc is just doing great, maxed out settings with maxed out ray tracing, and the benchmark that represents the absolutely worst case scenario holds close to 60 most of the time. Stray ray tracing implementation is extremely demanding, and it works a bit better on RTX GPU, but yeah, to get playable FPS, you need to lower the render resolution or the settings on both cards. One more game that prefers Intel async ray tracing pipeline is Watch Dogs Legion. 3060 already was significantly slower than Intel Arc without RT in this game. With RT, the difference got even higher. On Arc, it is a solid 30 FPS experience, on 3060 drops to mid-20s. After all the other results, Spider-Man Miles Morales doesn't impress a lot. However, it is still a solid result and a win for A770. Riftbreaker is a game that spends more than half of frame rendering time on ray tracing, and yeah, one more significant advantage on Intel Arc side. One more game that we wanted to test with enabled RT effects is Callisto Protocol. It features one of the most unusual RT effects, ray tracing transparency, that improves the transparent material quality by tracing rays through them and the geometry inside those objects. We tried, but we got a crash on Arc and didn't find any fixes. It can be a game problem since it's new and not that stable yet, but on 3060 everything works. Okay, the performance on 3060 was so bad that we decided not to include that test. Let's move on to something else. Previously, I mentioned that A770 has a huge advantage over 3060 in terms of props amount and a VRAM bandwidth, which can theoretically mean that A770 fits the higher resolutions a lot better. Let's try 4K then and see what happens. Sniper Elite 4K result is something hard to explain. Despite 3060's strong VRAM limitation, A770 advantage got smaller, not higher. Anyway, A770 is still impressively faster. Oh, and again, sensor reports 17 gigs VRAM consumption. Unlike Sniper Elite, Callisto Protocol shows a better advantage on Intel's side at 4K than in QuadHD. Again, A770 is faster, but in case of this game, lowering settings is required, at least to reduce significant drops below 30, even on ARC. The last game that we decided to test at 4K is Watch Dogs Legion. Results remind us of the one that we got with RT. ARC runs the game with a stable 30 and the RTX card just doesn't. A770 here scales better on higher res. So you have all the tests, all the results, and got the overall idea of what the chip design of ARC looks like, how it performs in different conditions, and what unexpected issues could happen. I think ARC A770 is a pretty competitive GPU, and moreover, until I'm waiting for 7900 XTX for a good price, A770 is a GPU in my main rig. You definitely shouldn't buy this card if you prefer old games with ultimate experience. You shouldn't buy it if you have not enough experience with different settings, API emulation layers and other PC enthusiastic things. But you should buy one if you want your PC to be future proof and if you want just to have a better value product. Of course, there are more nuances and details, but this is just a quick summary. And yeah, we also didn't touch the XeSS in this video. Probably we will do that in the future. I would just say I don't really care about DLSS. FSR works well on that GPU and XeSS is still not very popular, so FSR is the thing to go with here for now. but it's kinda personal thing. And finally, that's it. It was an Intel Arc A770. Don't forget to like this video if you enjoyed that, join Hard Roll Up Discord server, and as usual, stay up to date with HL.